All right, we're going to go and begin with practice exercise number 57 today. Practice exercise 57.
Calculator for a minute.
No calculator. Once again on this, as we're continuing to review basic algebra. So some Algebra 1 review here, which is beneficial, particularly, well, really to all of you. For those going into pre-cal next year, you need your algebra skills to be sharp, and those taking Algebra 2 next year, you need algebra skills to be sharp. Exercise 57, and you may begin. Just a little bit longer to be finishing. All right, put your pencils away if you would please and take out a pen. Pencils away, take out a pen. And exchange with someone else in your row so that you do not have your own. So exchange, pass back, and then Kendall passing up to the front, or perhaps doing a double switch here. All right. Sign your name as the grader, if you would please, right next to, or excuse me, at the bottom of page 16. Sign your name at the bottom of page 16 as the grader. Using pen. Pencils are away at this point. These are 12 points each. 12 points each. Going across the top row, your answers are 9, 20, 100, 2. For the next row going across, your answers are negative 24, negative 18, negative 16, negative 38. All right, these are 12 points each, so minus 0, of course, from 100 minus 1 would be an 88. If they missed 2, that'd be a 76. If they missed 3, That'd be a 64. Hopefully I didn't miss more than 3. Return to, yes ma'am.
Are we supposed to write the grade?
Oh yeah, I'm sorry, and write the score next to where it says exercise 57. Yes, write the score next to where it says exercise 57. All right, everyone have theirs back. All right, Chris, you were first. Did you get 100?
Yes, sir.
All right, any other hundreds, though not as fast as Chris? All right, guys, clean sweep. Guys were all perfect other than catching skills. And ladies, how many just missed 1? 2? Okay. All right, any questions on the ones we missed? Any questions on those that we missed? All right, go and pass those forward if you would, please. Take your homework out. Turn to page 152. Homework out. Open to page 152. On page 152, you did numbers 4 and 5. Page 152, you did numbers 4 and 5. That's in addition to copying out the theorems from the following page, page 153. And we've been looking at the relationship between arcs of a circle and their respective angles. And we said that in the past, we would have said that the arc of a circle was measured in units like centimeters or inches, but in geometry, I've explained to you that arcs can also be measured in what unit, Audrey? Degrees. And we said that the measure of an arc is directly determined by the measure of its central angle. So that since at the central angle of a circle there is a total of 360 degrees, or a paragon of revolution, so the arc of a circle also contains 360 degrees. However, 2 arcs that are both 74 degrees are not necessarily equal, Jamie. Explain why not.
Because the circles could be different sizes.
Right, if the circles are different sizes, 2 74-degree arcs and 2 different sized circles are different sized arcs, right? A larger circle would have a larger 74-degree arc. But within the same circle, or in congruent circles, arcs with equal degree measures would of course be equal. So we said if we wanted to find the measure of various angles in a circle, if we know the arcs, we can find these angles. And we've talked about 3 types of angles so far. First of all, to find the measure of a central angle, Chris,
It's equal to its arc.
it's just equal to its arc. That's how we got the measure of the arc in the first place, right? How about an inscribed angle, Kendall?
Equals half its arc.
Half of its arc. And what is an inscribed angle, Kendall?
It's an angle formed on the circle.
By
2 chords.
2 chords. Good. It formed on the circle by 2 chords. And then the last type of angle we looked at, and this was yesterday, Genesis, was if the arcs intersected inside the circle, we could find the measure of that angle by taking okay, so as we look at, let me do it this way. As we look at, let's just say, this angle, let me call these points A, B, C, and G. And what would be, how would I find the measure of this angle here?
From arc AG.
Arc AG, and also BC. I would take the sum. There we go. So an angle formed inside the circle is half of the sum of its own arc and the vertical angle's arc as well. And that's what we were practicing with in the homework last night. If you would go and hold your homework up so that I can see that it is completed. And you may have done the drawing and stuff right there in your textbook, I suppose. You necessarily have to draw the pictures. They're good. There's the theorems, we were going to get to in a moment. Sorry, there we go. That's what I was looking for. Good, good. You went ahead and did the markings, I assume, in the textbook, and I hadn't seen yours yet. Good question, Chris.
Yeah, have you ever had someone try and draw their own drawing before they realized that there was actually already a drawing drawn?
It's just easier to do it yourself, which is why I'm about to do it on the chalkboard myself.
My study hall during this.
So we're looking at this picture here with our circle. We've got this, the circle O. We've got a chord coming down here, CA. And we've got an intersecting chord, BD. They intersect at point P. It tells us in number 4 that arc AB is 50 degrees. So we're going to label that on the picture. Arc BC is 140 degrees. This is clearly not drawn to scale because 140 and 50 together is greater than 180, which means it should be what kind of arc class? A major arc. And it's clearly a minor arc. So clearly not drawn to scale. We don't trust our eyes though. This arc here was 150 degrees at CD. And it says to find angle DPA, finding this angle. Well, before you can find that angle, Ethan, you have to first find the arc. How big is the arc? You can look at your paper.
20 degrees.
20 degrees is correct. And once we know that this arc right here is 20, again, not drawn to scale, but that's okay, we don't trust our eyes. To find the angle, according to Genesis a moment ago, according to the proof that we did yesterday, we said the angle has to equal half the sum of the arcs. The two arcs in question here are the
20
and the
140.
we take half of that sum, we get 80 degrees is correct. The alternative would be to not find this at all, but simply find this angle. Well, its arc is 150, its vertical angle's arc is 50, that adds up to 200, half of that is 100. If you have 100 here, you have 80 here, it's an 80 degree angle. How many had an 80 degree angle for number 4? All right, so all my front people and my back people are questions this little triangle here.
I had 130.
100?
I think it said 240.
All right.
Just need to read better, I guess.
All right, questions? All right, does it make sense now? All right, let's take a look at number 5. Same picture and different given information this time. Also probably finding a different angle. All right, this time it tells us that CD, the arc, is 80 degrees. Clearly not drawn to scale. DA is 70 degrees. And then it says that arc BC is 3 times arc AB. What do I need to do with that, Quentin?
Call one X and the other 3.
Which one's which? You don't want to mess this up.
AB is X and CB is 3X.
Good. If this is 3 times AB, then AB is X and this is 3X. How many represented it correctly, first of all? But I've got to be able to figure out how big those arcs are. I need an equation here, Audrey.
4x.
Good, if you go all the way around the circle, you have x plus 3x plus 80 plus 70, that adds up to 4x plus 150 degrees. That has to equal 360 degrees. To solve, of course, we'll subtract away the 150, Audrey, to get 4x is equal to 210 degrees. And when we divide both sides by 4, we're going to get, it doesn't come out evenly, but x is equal to 52.5 degrees. So this is a 52.5 degree arc. And then BC, did you get 52.5? Did you get 52.5? Okay, BC comes to
157.5.
157.5 degrees. Now we can find angle BPC, this angle right here. In order to find this angle, Chris, I need to take
Some of the opposite angle and the angle, I don't know how to word it. 70 and 157, add them together and take out.
There we go. Add the two arcs, its own arc and its vertical angles arc, and take half the sum. When we add those together, Chris, it adds up to
227.5.
good, 227.5. And then we need to take half of that or divide that by 2 to get
113.5.
0.75, 113.75, or 113 3/4 degrees, or 113 degrees, 45 minutes. Any of those answers would suffice. I still have yet to get an answer with the minutes there. But anyway, I keep hoping one year somebody will do it. How many had one of those answers, though? Did anyone happen to have the minutes? Okay, whatever. All right, questions on this?
I got 140.
I have 156.
Oh, for this arc right here, which obviously then it would have affected this answer, okay? Questions on the homework. Does it make more sense now how to find the angle intercepted between the arcs?
I know what I did. Easy. Because I think I did 3x plus 150 equals what 360, and I didn't see x.
The additional x, okay? Well, let me go ahead and give you this circle, if you would. Maybe draw this on your paper as well so that you can mark on this. We've got a circle here, O. We've got a diameter, AB. We've got a radius, OC. We have a chord, BD. And then we have another chord, DE. And it intersects here at a point, P. Given that AB is a diameter, given that arc AE is 65 degrees, given that arc BC is 55 degrees, and given that arc BD is 120 degrees, I want you to find angle COA, angle BDE, angle ABD, and angle DPA. At your seats. I'm going to add just a little bit to this picture that I hadn't planned to add, actually.
Does that change anything?
It doesn't change any of these, no. But I am going to have you find angle OEP as well. You can. I don't know how much help it'll be, but you're welcome to look in your book.
Can I ask a question?
I'd rather you try to figure it out on your own. That'll help you more. About 2 more minutes to continue working and looking it over, trying to figure it out, and then we'll go over it. Then Shirley just sit quietly. Several people finishing up. 1 more minute. Great job, guys, on that practice exercise. Perfect. It's not often, ladies, you get a class full of perfect guys. Just saying. Choose carefully.
Look at the time.
I think I made them all sick.
Yeah, I feel from them up a little bit, not gonna lie.
Pencils down. Even if you're not finished, let's take a look at these together. First thing you want to note is the diameter, because on either side of a diameter class you have how many degrees? 180. So if arc AE is 65 degrees, if arc BC is 55 degrees, then on this side of the diameter I've already got 120 degrees used up. That only leaves how many degrees right here? 60 degrees. And then down below, I've got a 120 degree arc here. That leaves how many degrees right here? Also 60 degrees right here. All right? How many got the arcs, first of all, perfect? Oh no. Okay, here's the downside. You can't afford to miss arcs, because if you miss arcs, you're going to miss multiple angles probably. You must get the arcs right. Now we come to our angles, and the first angle I wanted you to find was angle COA. That's going to be this angle here. You have to ask yourself, what kind of angle is it, class?
Obtuse.
Well, yeah, it appears to be obtuse, but it's a central angle. It's formed by 2 radii. It's formed at the center. And a central angle is equal to its arc. How big is its arc? 125 degrees. So angle COA is 125 degrees. We then come to angle BDE. That is this angle here. Now we must ask ourselves, what kind of angle is BDE, class? It's an inscribed angle. And an inscribed angle is equal to half its arc. How big is its arc? 115 degrees.
I didn't get this one right.
Half of 115 would be 57.5 degrees, or 57.5 degrees, or 57 degrees, 30 minutes. How many had that answer? All right. Couple of you know. Now, you had missed the arc, right? So you were doomed to get the wrong answer.
I had 115. So I got all of them.
Okay, so you got 115. Remember, half the arc. Same thing. You forgot to take half the arc. Okay, so you got to remember that on the inscribed angle, take half. For angle ABD, what kind of angle is this, class? It's also an inscribed angle. And an inscribed angle is equal to half its arc. How big is its arc? 60, so angle ABD is 30 degrees. How many had 30? You guys had 60 again. All right? You got this one because this arc was not messed up. Good. All right? For angle DPA, that's this angle here. There's actually 2 ways you could solve this. But the conventional way is to look at this and say, hey, this angle is formed inside the circle by intersecting chords. So this angle is going to be equal to, class, half the sum of arcs. Now, its own arc is really easy. 60. How big is the vertical angle's arc? 115. So we have a 115 for the vertical and 60 for it. That means the sum of the arcs, class, is... I'm sorry? 100, yeah. The sum of the arcs is 175. Half the sum, 87.5 degrees. How many had 87.5 degrees for angle DPA?
How many do you think me and Quentin had?
All right.
I had 88.5.
Questions on this? Now, there's another way you could have solved it, though. If you remember that BDE was 57.5, and if you remember that ABD was 30, because right here, class, we have a little triangle. This angle is outside the triangle. It's an exterior angle. And an exterior angle is equal to the sum of the opposite interior, 87.5. So as you're finding angles, can you use triangle facts that you've learned? Absolutely. And that's what we had to do on the last one. Angle OEP, this little guy here. What kind of angle is OEP? It is not an inscribed angle, is it? Because an inscribed angle is formed by two chords. I have a chord here. That's not a chord, is it? So I can't say it's half its intercepted arc. It doesn't have an arc, right? But I can look at some of the angles around it. For instance, we already said that this angle at P was 87.5 degrees, correct? The vertical angle right here is also going to be 87.5. And this angle, this piece right here, is a central angle. It has to equal its arc, 65. And if I look inside the triangle right here, I'm allowed to have how many degrees in the triangle? 180. Of which 87.5 and 65 are already used up. How many degrees are left? 27.5 degrees. Did anyone get 27.5 here? Does it make sense how you should have found it using the triangle relationship? Questions on this picture? Yes, sir.
Did you expect any of us to get that last one?
I know, well, you certainly could have.
You could have, I'm just asking if you expected it.
I kind of was hoping at least one or two. But, because again, it's just a matter of you have the knowledge, can you apply the knowledge? And that's what exercises like this are great for, is forcing you to then apply the knowledge. Yes, a question?
On the last one I had 55, which is double. If I had half that, would that work all the time?
How did you come up with 55?
Because I sent it EO and then the chord right there.
Now, how do you know how big this arc is, though?
I figured that EO would be a diameter.
Ah, interesting. It would be a diameter of which you've already got 65 and 60, which leaves 55 degrees here, which would be 27.5. Clever. I like it. You just got to take half, but yeah. Okay, great thought, because the extension is a diameter. Bravo. I like when you think outside the box. Nice. You use an auxiliary line in one of these. All right, good. All right, any other questions, comments on this?
You made his day.
All right, I like it. All right, good, good. All right, well, clear your desk, except for a clean sheet of paper, a pencil, and a calculator. That was your practice round. Here comes the real thing. Clear your desk except for a sheet of paper, a pencil, and a calculator. The paper is for a cover sheet. Do not write anything on your paper. In a rare move, you're going to actually take the quiz on my quiz copy. You're going to take the quiz directly on the quiz copy. This is to save you the time and trouble of having to draw circles and lines on your own paper. It's just, it's a time waster if you try to do it. And frankly, it's hard to draw a circle. I have a computer that draws them great. Okay, so we're going to let the computer do all the work here. Other than finding the answers, your brain has to do the work for that. So you got a sheet of paper, pencil, and calculator. You take one, pass it back. Take one, pass it back. Take one, pass back.
Is it pen and pencil?
Just pencil for now. Now, at the top of the quiz, there is not a blank for you to write your name, but there is space for you to write your name. So at the very top of the quiz, put your first and last name. And today's date, which is January 15th, 21. 1/15/21 today's date. Ethan failed. 1/15/21 today's date. I've given you information. I've given you a diameter. I've given you 3 arcs. You find the 4 remaining arcs and the 6 specific angles that I asked for. Mark all of your markings on this paper. You may, of course, use your calculators. Right. Keep your answers covered as best you can, maybe covering the column as opposed to covering the picture with the paper. Begin. About 2 more minutes to be finishing up. 2 more minutes to be finishing. This time I need you to go and pass your quiz to the front. Go and pass your quiz to the front. We'll take a look at these on Tuesday when we come back to school. In the meantime, if you would take your notebooks out, turn to the Theorems Corollaries section. Theorems Corollaries section of your notebook. Let's take a look at the first theorem that you copied down last night. Look at that first theorem, Theorem 44, that you copied for homework. Theorem 44.
We're gonna
Have that out. I'm sorry?
We're gonna be proving it in the book.
We'll be taking a look at it here in just a moment. Good. Already saw that. Quickly, Theorem 44. Thank you. Good. 4445 and 4445. Excellent. Go ahead and read Theorem 44 for us, if you would, nice and loud. Audrey. All right, so we see this on the sideboard there. That next one up is that an angle formed by a chord and a tangent is equal to 1/2 the intercepted arc. Let's take a look very quickly at what the proof would be. We're not going to take time to prove it here, but suppose we had a tangent line. There's our point of tangency. And at the point of tangency, some chord is drawn. Let's just go with a chord something like this. Let's call the point of tangency T. Let's call this point A. Let's call this line LN. And circle O. So we want to prove that angle ATN, this angle right here, is equal to 1/2 its arc. Well, remember, the arc is cut off by the chord itself, isn't it? The chord intercepts arc AT, and that chord is the chord that the angle would equal 1/2 of. At least that's what the theorem says. How would we prove this? You actually saw this in your book as you were copying it. The thought is start by drawing a diameter from T through O to the other end, right? 2 points determine a straight line, and that line may be extended or limited at any point. Let's call this other end of the diameter maybe D. And then this point now is predetermined, so now let's find this point to this point. 2 points determine a straight line there. In drawing a diameter class, we've divided our circle into 2 equal semicircles. That means that this angle at A is inscribed in a semicircle. And any angle inscribed in a semicircle class is a right angle. Good, Chris. Try that again. Class, any angle inscribed in a semicircle is a right angle. Any angle inscribed in a minor segment is obtuse, and any angle inscribed in a major segment is acute. But if it's inscribed in a semicircle class, it's a right angle, which means I have a right triangle, don't I? Let's consider for a moment these 2 angles, 1 and 2. Angle 1 and angle 2 are acute angles, correct? We know that the 2 acute angles of a right triangle are
45.
not equal.
Complementary.
Not necessarily 45,
Acute.
but always. This is one of those things I told you, you have to memorize it, put a star next to it. You're going to see it on every exam here on out. The acute angles of a right triangle are complementary. You've got 180 degrees, 90 of which are here. That leaves 90 degrees here. The 2 acute angles of a right triangle class are complementary. So I know that angle 1 and angle 2 are complementary because, class, the 2 acute angles of a right triangle are complementary. Any angle inscribed in a semicircle is a right angle. But we also know this. I drew a diameter. And a diameter is what to a tangent at the point of tangency, class? Perpendicular. So I know that dt must be perpendicular to ln, which means that angle dtn is a right angle, correct? But angle dtn, this right angle, is equal to the sum of its parts. Angle 2 and angle atn, correct? That means these 2 angles add up to a right angle. And if 2 angles have a sum that is a right angle, those 2 angles are complementary by definition. So angle 2 and angle ATN are complementary. Wait, 1 and 2 are complementary. ATN and 2 are complementary. Angles complementary to the same angle are equal. That means angle ATN is equal to angle 1. What kind of angle is angle 1, class?
Acute.
Inscribed. It's an inscribed angle. An inscribed angle is always equal to half its arc. Half its arc. Very important. Hopefully you got that on the quiz. An inscribed angle is equal to half its arc. What is the arc that angle 1 intercepts, class? So that means, therefore, that angle 1 is equal to half its arc AT. But if angle ATN is equal to 1 and 1 is half of AT, then ATN is half of arc AT. That's the proof we would have done. Would have taken a long time to actually write it all out, talking through it much quicker. Do we understand the proof, though, of all we talked through? So, if you have an angle formed by a chord and a tangent, it's equal, class, to half its arc. Interesting, if the vertex is on the circle, it's going to be half, right? Inscribed angles have the vertex on the circle. Angle formed by chord and tangent has that vertex on the circle. So remember, on the circle, half the arc. In the circle, half the sum. At the center, just equal to the arc. But anyway, if you want to try to memorize some sort of pattern here to that. Look with me, if you would please, at page 153. Page 153 now in your textbook. Page 153. Now let's look at exercise number 5. Page 153, exercise number 5. We're going to use the picture just above the shaded box here, which was, of course, this circle O with a point of tangency P, a tangent line AB, and a chord PC. It says if arc PC equals 78 degrees, number 5, how many degrees are there in angle BPC? Well, what two lines form this angle, class? CP, which is a chord, and AB, which is a tangent. And an angle formed by a chord and a tangent equals half its arc. We need to memorize that fact. An angle formed by a chord and tangent equals half the arc. On the example on the board over there, we have a 126-degree arc. We have a 63-degree angle. The angle's half its arc. Well, here the arc is 78. So, class, the angle must be 39 degrees, because the angle formed by a chord and tangent, class, equals half the arc. Look at the second part. It says, well, what if we knew that the angle was equal to 54 degrees? Then how big would the arc be, class? 108, because 54 is half of 108, and an angle formed by a chord and tangent equals half the arc. Questions on that? Tonight for homework, you're going to be completing a handout. This handout will give you practice with all the different things you see, or used to see before I took them down before the quiz, on the side bulletin board. Central angles, inscribed angles, angles formed inside the circle by intersecting chords, angle formed on the circle by a chord and tangent. You'll have all of them on the handout this evening. So your homework tonight, complete the handout. Actually, you can pass these back. I'd be lazy. All right, so complete this handout tonight for homework. It looks a little bit like the quiz you took, except there's a couple more lines placed a little bit differently. Now, you'll notice that I do not start by asking you to find any arcs. But you can't do the exercise if you don't find all the other arcs, okay? So even though I don't say find these arcs, you have to find the arcs in order to do the exercise. Make sense? All right, that's your homework. We'll take a look at that on Tuesday. We'll take a look at the quiz you took on Tuesday as well. And then we'll move into our last arc angle thing that we have to know. All right, so a lot of arcs and angles, application of knowledge. And when the bell rings, you'll be dismissed.